When humans speak of greatness, we often look up to the sun, a massive sphere of fire that sustains this entire planet, governing every breath of life. With a size more than 1,000,000 times that of Earth, the sun seems like the pinnacle of cosmic power. But that is only our perspective. In the endless ocean of the galaxy, the sun is not a giant, but merely a speck of dust drifting quietly among hundreds of billions of stars. There are entities so vast they could swallow the sun like a drop of water in the ocean. And today, we step into the realm of one of those giants, a star so enormous it surpasses all human imagination. UY Scuti. In 1860, at the historic Bonn Observatory in Germany, astronomers were diligently observing the night sky through primitive telescopes. During a major survey to catalog hundreds of thousands of stars, they noticed a faint point of light in the constellation Scuti changed in a peculiar way, sometimes brighter, sometimes dimmer. A few years later, it was officially named UY Scuti, the 38th variable star in the constellation Shield. It lies about 5,900 light-years from Earth, deep within the Milky Way, obscured by thick clouds of cosmic dust. It is a hidden monster of plasma. Now, let's truly grasp the scale of UY Scuti. Its radius is estimated to be about 909 times that of the Sun. However, this number is only approximate because its outer layers constantly fluctuate, expanding and contracting like a colossal mass of trembling plasma. If placed at the center of our solar system, its outer layers would not only engulf Mercury, Venus, Earth, and Mars, but extend all the way to Jupiter's orbit. At its largest expansion phases, it could even approach Saturn's orbit. Imagine you're on a commercial airplane, like a Boeing 747, flying at an average speed of about 900 kilometers per hour. Around Earth, it would take roughly 45 hours to circle the equator. Exhausting, but doable. Around the Sun, if such a route existed, the plane would need 202 days, over 6 months, non-stop, to complete one lap. Around UY Scuti, with that same plane, completing a single lap around this giant would take 1,100 years. If your ancestors had started flying at the time of the founding of the United States in the late 18th century, when the Declaration of Independence was signed, then even today, after more than 200 years of history, war, development, and space exploration, their descendants still would not have completed a full circle around this star. But what makes UY Scuti truly strange is not just its size. Normally, we think that the larger something is, the heavier and denser it must be. But UY Scuti is the complete opposite. Despite its enormous volume, its mass is only about 7 to 10 times that of the Sun. This gives it an extremely low average density, even thinner than the air in the highest layers of Earth's atmosphere. It is not a solid body, but more like a vast, constantly shifting cloud of plasma. Gravity at its surface is therefore very weak, allowing material to be easily blown away by stellar winds. As a result, UY Scuti has no clear boundary. It gradually fades into space like a colossal cosmic mist, immense in appearance, yet fundamentally hollow. UY Scuti shines 340,000 times brighter than the Sun, yet in reality it is almost invisible to the naked eye, shrouded by cosmic dust. Its brilliance does not make it easier to see. If the Sun is a warm father nurturing Earth, then UY Scuti is a tyrant. Any planet near it would be swallowed or melted by its intense radiation. Its greatness comes at the cost of destroying all potential life around it, and that is only part of the story. The surface temperature of UY Scuti is only about 3,550 degrees Celsius, significantly lower than the Sun, around 5,500 degrees. Yet it still shines more than 124,000 times brighter than the Sun. Its nature is not that of a dense object, but rather an extremely diffuse cloud of matter. Its density is so low that surface gravity is weak, allowing particles to escape easily. As a result, UY Scuti is constantly losing mass through powerful stellar winds, blowing away its own outer layers and forming a vast surrounding envelope of material. In a sense, this star is both existing and slowly dissolving itself over time. So in such an extreme environment, a hypothesis arises. If planets exist orbiting UY Scuti, where could life possibly emerge? With the Sun, the habitable zone lies relatively close, where water can exist in liquid form. But with UY Scuti, an extremely luminous red supergiant, the zone where liquid water could exist must be incredibly far away, on the order of hundreds to 1,000 AU. This distance is even farther than Pluto's orbit in our solar system. That leads to a remarkable consequence. If a planet exists in that zone, time there would flow in a completely different way. A single year on such a planet could last thousands of Earth years. Each season, summer or winter, could last up to 2,500 years. If life existed, it would have to adapt to timescales so immense that an individual might experience only a fraction of a single season in its entire lifetime. However, distance is not the greatest problem. UY Scuti is a variable star, constantly fluctuating dramatically in size and brightness. Its radiation is unstable, at times strong enough to strip atmospheres, tear apart DNA, and incinerate any complex life forms. Moreover, the star is ejecting millions of tons of material every second in the form of massive stellar winds filled with toxic gases and dust. As a result, even the habitable zone around UY Scuti is almost entirely unsuitable for life. It stands as a warning from the universe. Not every giant star gently nurtures life. Some are merely colossal nuclear furnaces, burning and destroying everything around them in the most brutal way. The larger they are, sometimes the harsher and more desolate they become. And that very brutality reveals a deeper truth. UY Scuti is not only dangerous to its surroundings, but is also destroying itself from within. This star has entered the final stage of its life. It has nearly exhausted the hydrogen in its core,
and has begun fusing heavier elements, such as helium. This transition creates instability, causing its outer layers to expand and contract continuously, like a colossal body losing control. With each pulsation, UY Scuti loses more mass. Layers of gas and dust are blown outward, forming a thick envelope surrounding it. Inside, the core contracts and heats up, while the outer layers expand further and become increasingly fragile. Paradoxically, its enormous size is actually a sign of weakness. It is no longer stable, it is gradually falling apart. And then, when its final fuel is exhausted, everything will end in the most violent way. UY Scuti may evolve into a Wolf-Rayet star, where powerful stellar winds strip away nearly all of its outer layers, exposing a core rich in heavy elements. Or it may collapse directly under its own immense gravity. Either way, the outcome is almost certain: a massive supernova explosion. The shock wave from this explosion will surge through space, sweeping away everything within tens of light years. UY Scuti will release more energy than the total output of the Sun over its entire 10-year lifetime. For a few weeks, it could shine so brightly that it would be visible from Earth even during daylight, despite being thousands of light years away. In rare cases, such a death could even produce a gamma-ray burst, one of the most energetic events in the universe. After the explosion, what remains of this giant? There are two main possibilities. Scenario 1, a neutron star, an ultra-dense corpse where a single teaspoon of matter would weigh as much as Mount Everest. Scenario 2, more likely, a black hole. The core of UY Scuti is so massive that it would continue collapsing until it pierces the fabric of space-time, creating a region of void that swallows all light. So if one day UY Scuti can no longer hold its place, which star will become the king of stars? Among the most notable candidates to replace UY Scuti, WO G64 stands out. It was once estimated to be about 3,000 times the size of the Sun, though more precise measurements in 2009 revised that figure down to around 1,504 times. It is a red supergiant in the Large Magellanic Cloud with similar variable characteristics. Westerlund 1-26 has also been cited by NASA as one of the largest known stars, exceeding 1,500 times the Sun's size. Meanwhile, NML Cygni reaches about 1,639 solar radii and consistently ranks among the top giants. VY Canis Majoris, despite past controversy, has been measured at around 1,420 solar radii, while KY Cygni, though smaller, still reaches approximately 1,033 times the Sun's size. There have even been stars once estimated to be between 1,800 and 2,200 times the Sun's size, but as observational technology improved, new measurements significantly reduced those figures, showing that determining the largest star remains an unsolved problem. So when we ask which star is the king of all stars, the answer is not a specific name. In the universe, that title belongs to no single star in an absolute sense, because all our numbers are only estimates, and they may change as human knowledge advances. The throne has no permanent ruler. and it is entirely possible that the true king of stars is still hiding somewhere in the vast universe beyond anything we have ever observed.